Have you ever just stopped and wondered how that perfectly cool air from your AC just shows up in every single room? Or, how heat gets all the way to that one chilly room at the end of the hall? Well, today we're going to pull back the curtain on that hidden highway system running through your walls that makes it all happen. We're talking about air ducts, right? It's one of those things we totally take for granted. But there's this amazing silent network just out of sight working around the clock to keep us comfortable. So in this explainer, we're going to map out that very network piece by piece. And honestly, that's the absolute best way to picture it. Ductwork is literally the highway system for a building's air. It's just a whole series of connected tubes and passages designed specifically to get conditioned air from your main unit out to every single room that needs it. Okay, so if we're going to understand this air highway, we have to start with the basics, right? Let's talk about what these ducts are actually made of. Let's look at the building blocks. So before we even jump into the different materials, we've got to talk safety. It's super important. The National Fire Protection Association puts materials into two main buckets. You've got Class 0, which is the gold standard. It won't produce any nasty fumes, even if there's a fire. Then there's Class 1. It's still perfectly fine, but under really high heat, it might release some stuff that could cause minor issues. It's a really key safety difference. Now, most of the ducts you're ever going to see are made of metal, and for good reason. Galvanized steel, that's your everyday workhorse. It's strong, it lasts, and it doesn't break the bank. For really hot situations, like say the exhaust hood over a giant grill in a restaurant, you'd step it up to carbon steel. Aluminum is a great option if you need something lightweight, though it is a bit pricier. And then, for very special cases, like a science lab with corrosive fumes, you might see something like stainless steel or even copper. But hey, it's not all about metal. Sometimes a non-metallic duct is actually the better choice. Fiberglass, or FRP, is awesome where there are chemical fumes because it just won't corrode. PVC is a dream to work with when you need a system with a ton of custom turns and branches. There's even this cool hybrid called PVS that gives you the muscle of steel with the workability of PVC. And believe it or not, for permanent systems built right into the foundation of a building, you might even find ducts made from concrete. Okay, here's the term that trips people up at first: gauge. It's just a number that tells you how thick the metal is. But here's the one thing you absolutely have to remember, and it's a little backwards. The lower the gauge number, the thicker and stronger the metal is. So 26 gauge steel is actually thicker and tougher than 30 gauge steel. Just remember, lower is thicker. All right, so we've got our materials down. Now let's talk about shape. And this might seem like a small detail, but you're about to see how the geometry of a duct can have a massive impact on how well that whole air highway actually works. First up, we have the undisputed champion of efficiency, the round duct. Think about it. Because it's round, the air flowing through touches the least amount of surface area possible. That means less friction, less energy lost. It's just plain efficient. They're also easier to seal up and insulate. The only real drawback, they need a bit more headroom, more vertical space in the ceiling. Now, because we don't always have a ton of ceiling height, the rectangular duct is incredibly common. It's fantastic for squeezing into those tight spaces between floors. Plus, those flat surfaces make it super easy to connect other branches. The trade-off, of course, is that it's just not as efficient. You get more friction, you use more material to make it, and sealing all those corners perfectly can be a real challenge. And that brings us to a golden rule for rectangular ducts, the aspect ratio. That's just a fancy way of saying the ratio of the duct's width to its height. For the best airflow, designers always try to keep that ratio between 1:1, which is a perfect square, and 4:1. Once you get much wider and flatter than that, kind of like a pizza box, it gets really, really bad at moving air efficiently. So what if you need to save space, but you still want some of that round duct efficiency? Well, say hello to the oval duct. It's kind of a best of both worlds option. It's way more efficient than a rectangular duct, but doesn't take up as much vertical height as a round one. Plus, they can look pretty cool in places where the ductwork is left exposed. The only real headaches are that making the fittings can be tricky, and they can be a pain to ship. Okay, we've picked our material, we've chosen our shape, but we're not done yet. We've got to protect that precious conditioned air while it's traveling down our highway, and that's where insulation comes in. This part is absolutely crucial. So why do we bother? Well, there are three huge reasons. First, and this is the obvious one, it keeps your hot air hot and your cold air cold as it moves through the building. Second, it stops condensation. You know how a cold glass sweats in the summer? Insulation stops that from happening on the outside of your cold ducts. And here's a cool bonus. It actually makes the system quieter by muffling the sound of air rushing inside. Yeah, that's the big question, right? Do you really have to insulate every single inch of ductwork? Not necessarily. There's a really clear, simple rule of thumb that designers use to figure this out. And here it is. It's super simple. If the temperature difference between the air inside the duct and the air surrounding the duct is more than 15 degrees Fahrenheit, you need to insulate it. Period. Think about a duct carrying ice-cold AC air through a blazing hot attic in July. You're definitely going to need insulation there. It's a simple rule, but it's so, so important. Now, just in case you're curious about the science behind all this, the amount of heat a duct loses or gains really comes down to three things. First is the material itself. That's the U value. Second is the duct's surface area. Obviously, a bigger duct has more area to lose heat from. And third is that delta key, which is just the fancy science term for the temperature difference we were just talking about. Awesome. We've got our building blocks now. Material, shape, insulation. So now it's time to put it all together and see the big picture. Let's look at a few of the most common ways these ducts are actually laid out. These are our highway maps. One of the most common layouts you'll see is called the extended plenum system. You start with this big box right off the furnace, which is called a plenum. From there, a large main trunk line runs right down the middle of the building. Then, smaller branch ducts tap off that main line to feed air into all the different rooms. It looks exactly like the trunk and branches of a tree. Another really popular design is the radial system. With this one, instead of a big central trunk, you have a bunch of smaller, individual ducts that run directly from that central plenum straight to each room. It looks just like the spokes on a bicycle wheel, with each duct taking its own direct path to its destination. Now, this one is a really clever twist on that first system we talked about. In a reducing trunk system, that main trunk duct actually gets physically smaller after each branch duct pulls air out of it. And why would you do that? Well, it makes perfect sense. There's less air flowing through the trunk further down the line, so you don't need such a big duct. It's a really smart way to save material and make the whole thing more efficient. Wow. Okay, we have covered a ton of ground here, from what ducts are made of, to their shape, to how they're laid out. So let's wrap this all up with a quick little cheat sheet to help all the most important points stick in your head. Here are the big takeaways. For material, think metal for strength and non-metals like plastics for flexibility and custom jobs. For shape, just remember, round is for efficiency and rectangular is for fitting into tight spaces. For insulation, that 15-degree rule is your best friend. And for layout, you've got simple, common systems like the radial and more efficient designs like the reducing trunk. So there you have it. You now know the A to Z of how this incredible air highway gets built, from its materials all the way to its final map. But, that brings up a really interesting new question. If we've built the highway, what determines the speed limit for the air traveling on it? That's a topic for another time. Thanks for watching.